Myself, Jaimin Pandya, Assistant Professor from LJ Institute of Engineering and Technology. So let's start with the chapter number 1. In this lecture, we'll discuss about equilibrium governing separation process such as distillation, absorption, adsorption and drying. Then we'll talk about the rate governing separation process such as osmosis, reverse osmosis and dialysis. So let's start with the equilibrium separation process and rate governing separation process. Most of process involve either separation of solute from the solvent or separation of mixture of solute. It may be not that the component those need to be separated are in mixture naturally. In order to effect separation, one has to put either energy or extra material from outside to disturb the stability. As discussed in earlier session, the separation process are divided into equilibrium separation process and rate governing separation process. In equilibrium governing separation process, the product phase are in equilibrium with the inlet phase. In rate governing separation process, difference of rate of physical transportation of species bring the separation of specific separation process under the two category. So let's start with the equilibrium separation process. So this is an example of rate governing separation process. Most of membrane separation process are rate governing separation process in which membrane provided to separate the solute and solvent. Most of separation process or most of rate governing separation process are based on membrane separation process. Then next example is a equilibrium governing process. Distillation is one of the example for equilibrium governing process in which two phase comes in equilibrium and separation becomes possible. When the heat applied to the mixture of component, the mixture of component evaporated and separated due to the boiling point difference. So this is all about the equilibrium and rate governing separation process. Let's start with one example of equilibrium governing separation process. So let's discuss about the distillation. Distillation is based on difference in boiling point of a component in mixture. The component having a lower boiling point will go to vapor phase, leaving behind the other component in residual mixture. In this process, external heating is required to heat up the system. Therefore, top vapor phase is condensed and reach in one component and the residual liquid is a reach in other component. This process is known as a flash distillation. In another process, a part of condensation stream from the top is recycled down to the column. This is known as a reflux. In another process, a part of condensation stream is from the top is recycled down to the column. This is known as a reflux. In this case, there is a initial mixing of liquid stream coming down and vapor going to up. This operation is carried out in countercurrent fashion and this enhances the efficiency of process. This is generally used for the separation of aqueous mixture of various organic solvent like toluene, benzene, acetone and ethyl benzene. So this is all about the distillation and this is one example of the distillation. Now let's discuss about absorption technique. In this process, a vapor inert gas is absorbed in liquid stream. This vapor is a soluble in liquid. The liquid stream reach in a solubilized vapor component separated by distillation or some suitable technique. The liquid can be recovered and reused in process itself. An example is removal of ammonia from ammonia water mixture using water as a solvent. Removal of carbon dioxide from mixture of air and carbon dioxide using solvent like primary and secondary or tertiary amines is another example. Typically, this operation is carried out in countercurrent manner. To enhance efficiency of this process, sometimes the pack bed or stage bed like trays are used to have better mixing during the transfer process. It may be mentioned that absorption is a bulk phenomena. The gaseous solute are transported to the bulk liquid stream. It may be not that the effect of separation a metal is introduced in a system. So this is all about the absorption process. To understand this, let's consider this example. Let's consider this is a one exhaust gas which enter to the CO2 absorber, and this CO2 absorber absorb the CO2 and separate other gases and CO2, and we can get pure gas from top of this bottom, and other gas can transfer using this bottom. Then this amine will be transferred to another column and deabsorption process initiate, and where we can get other component and we can get pure CO2. So this is all about the absorption. Now let's talk about the adsorption. Absorption process is a surface phenomena where absorption process is a bulk phenomena. In adsorption, separation of solute by transporting it from gaseous or liquid stream on solid surface is known as a adsorption. As opposed to absorption is a surface phenomena, the solute is fixed on solid surface only. Typically, the solid surface is specific for particular component present in feed stream. For example, in liquid stream having organic as well as inorganic compound, the organic are preferred to adsorb on surface of activated carbon. Typically, in a bed, the adsorption particles are kept and fluid is pumped through the system for intimate mixing. In the process, the solute is transferred to the solid phase. After some time, the solid phase is completely saturated and transfer of species become extremely slow due to the lack of driving force. In such case, the bed has to be replaced by new adsorbent, or bed has to be regenerated by the suitable washing protocol. It may be not that the reassembled lower or particle size of adsorption provide sufficient surface area for separation. Removal of organic from the aqueous mixture using activated carbon is an example of adsorption. It may be not that effect of separation, a metal is introduced in a system. So now let's talk about the drying. In drying, water vapor from solid material are removed by using vapor stream to a acceptable small limit. Generally, it is carried out by the applying thermal energy as compared to introduce of matter in case of absorption or adsorption. The process efficiency depends on temperature, relative humidity, and other thermophysical property of drying vapor as well as temperature and other thermophysical property of solid. Now let's talk about the rate governing process. Most of membrane based process are rate governing separation process. The main crux of the separation lies in difference transport of various species through the membrane. The driving force of such transport is a generally gradient of chemical potential. If we recall the definition of gradient of chemical potential, it is composed of four parts. These are concentration gradient, pressure gradient, temperature gradient, and electrochemical potential gradient. Presence of these result into the effect. Some of these systems are described such as the osmosis. So let's discuss about the osmosis. Osmosis is observed when solution is a separation from a solvent by semi-permeable membrane. Difference in osmotic pressure across membrane causes the transport of solvent. Actually, osmotic pressure is a collective property and it is a function of concentration. Therefore, the concentration gradient of solvent is a main driving force in osmosis. In this case, solvent flow from solvent side to the solid side until the solvent activity becomes almost equal in both sides. This results in generation of hydrostatic pressure difference between two sides, which known as the osmotic pressure. So this is all about the osmosis. Now let's talk about reverse osmosis. It must be understand that osmosis is a natural phenomena. In case of reverse osmosis, pressure is applied on a solute side extremely so that osmotic pressure is overcome and solvent are forced out of the solute side. The efficiency of this process depends on the porosity, morphology and thickness of the membrane. This factor influence the transportation of solvent through the membrane in assembly, thereby detecting the throughout of the process and the quality of the product. Since reverse osmosis membrane have a very small pore size, this is used for the separation of lower molecular weight species such as a salt. A salt have very low osmotic pressure. The operating pressure in feed side of a reverse osmotic process is therefore extremely high. This will be lead to the deposition of salt near the membrane surface, leading to build up of concentration boundary layer. Therefore, pressure gradient in this system lead to a concentration difference. So this is all about the reverse osmosis. So let's discuss about the dialysis. In this case, two liquid stream are separated by permeable barrier or membrane. In feed side, specific set of solute are permeate through the membrane to other side. The upstream feed is known as a feed side or downstream is known as a dial salt. This typical dial salt is a stream is pure distilled water. Thus the concentration gradient between two stream is the maximum. The transport is effective by the concentration gradient between two stream. The duration of specific entire depend on rate of solute through the membrane. An example is the removal of urea and keratin from bloodstream is the best example for the dialysis. So in dialysis, the separating molecule in a solution by the difference in their rate of diffusion through a semi-permeable membrane. So this is all about the dialysis. So in this lecture, discuss about the various topics such as the equilibrium rate governing separation process, such as a distillation, absorption, adsorption, drying. Then discuss about the rate governing separation process such as a reverse osmosis, osmosis, dialysis. So this is all about today's lecture. I am completing my lecture here. Thank you.